All right, friends and neighbors, welcome back. We are doing Chapter 29 in the CCNA, Volume 1, Implementing IPv6 Routing. Now, we've done some examples previously, but we're going to focus on a couple of areas on the routing table and all the different kinds of static routes in this particular video. This is also a little exciting because it is the end of Volume 1. So next up, we got Volume 2, some of the other areas we're moving up the protocol stack. So in this video, of course, we'll do the key topics. We'll talk a little bit about what we're going to cover. The exam section is IP connectivity, interpreting the components of the routing table, right? All the stuff that you see in a routing table. And it's really important that you be able to take a look at a routing table entry and process all of the fields inside there. So we'll look at those. Configure and verify IPv4 and IPv6 routing. We'll talk a little bit about troubleshooting, what you can look at, what can be helpful there. And then the four magic static routes we've got there, or I should say the four magic routes we're going to talk about. We have the default and the network routes, and then we've got host routes that you can put in there, and then floating static routes. And we'll finish up with the do I know this already questions. Here we go. Now, our key topics in this chapter will be methods by which a router can build IPv6 routes, and mostly what we're talking about here is what does it mean to put in a static route, or the different ways that we can do that. Rules for IPv6 connected and local routes, right? When we add these to our routing table entries, they look different, right? So we'll examine those, and then we'll talk a little bit about how we process the routing table. There are a number of different kinds of static routes and a number of different ways that we can put those in there. We'll talk a little bit about those. And then our admin distances, those also appear in our routing table, so we'll make sure we look at that. There's only a couple in this chapter. And then the troubleshooting, there's two really big ideas. One is the list of reasons for IP static route problems that result in a route being in the routing table but it doesn't work correctly. And then the other one is that you put in a route and it doesn't appear in your routing table at all. Why would that be the case? So we'll talk about both of those issues. Now, the first thing that we're going to talk about is when you first configure a router, right? So the router link comes up, so you're connected to a switch, and you've done a no shutdown on the interface, and you've given it an IP address. And what that gives us is a connected and a local IPv6 route. Now, it turns out that this is very similar. In fact, a lot of the stuff that we're going to talk about in this chapter has a lot of similarities between IPv4 and IPv6. The same things happen, right? If I bring a router up that's an IPv4 router and I give it an IP address and the link is up, I get an entry for that particular network and I get a local IPv4 route. Well, we're going to see the same thing here. Now, the other thing that we want to remember is that we can route via the globally unique address, the unique local address, and the link local address. So we can use all of those entries, but there are rules that we don't do things exactly the same way. And there's a very particular reason for that, and that is how the routing table is processed. And we do not create local routes for link local addresses. So even though you know your neighbors, and even though you have a link local address, we don't create routing table entries for those, and we'll see those here in a second. So when we add routes to the routing table, they get added based on a couple of criteria, right? Whatever address you put on the interface and the mask, we're going to get an entry for that. We're going to get an entry for the interface itself, and then that allows us to do configuration of the static routes themselves. And then lastly, if you're running a routing protocol, right? So if you're running OSPF v6 or something like that, then you're going to get dynamic routes. Now, an important thing to remember is that if an interface goes down, any route that's associated with that interface, anything that was learned via that interface also goes down. It's removed from the routing table. So a single interface can impact a lot of different routes. So let's take a look at a quick demo to remind ourselves where we are, and then we'll talk more about some of the details. So here is the topology that we've been working with for the last couple of chapters, and I'm just going to peek at router 3 here. Now, as a reminder, we are going to do a couple things when we start doing IPv6 networking, right? We're going to turn on IPv6 unicast routing. And then under the interfaces, we're going to have the IP addresses. And then we'll add our static routes. Now for this part of the video, I'm going to skip these static routes and we're going to focus on just this 444 network right here. So what we're going to do is do a show IPv6 route. And these are the screenshots that appear on the slides as well. So the thing that I want to focus on is these two right here. Now in this entry, this is we'll take the L route. Well, what's the L? If we go right up to the top here, we know that that is a local route. Now the local route gets added because it's the IP address that I gave to this interface. And it's important because while we know that we've done the zero suppression here, take a look at that mask. That 128 right there means that this is the entirety of the address. This matches the entire thing. So this is the local route for the interface. And then we have the connected route here. And this is a combination of the address that I use, but look at the mask that's applied here. So this is the subnet that's being applied to this particular network, so the directly connected route. Now the other thing that we want to realize is that we've got admin distances here for both of these. The 00 indicates the admin distance and the metric associated with these routes. You can't get any better than these. If we compare that to the static routes that are above that, we can see that a static route has an admin distance of 1. The higher you go in admin distance, the worse the route is, or the less preferred the route is. So we're going to always prefer directly connected and local routes over static routes, and then static routes are almost always preferred over anything else like OSPF. Now when we start adding static routes, there's a couple of ways that we can do this. Now I have my particular preferences, but when we're doing IPv6 routes, it's not any different than we used to do with IPv4 routes, right? We're still going to say, what's the prefix, what's the network that we want to get to, what's the mask associated with that destination, and then how am I going to get there? And as you can see from the arguments here, once you put in the prefix or the destination network and the mask, there are a lot of options to each of these arguments. So there's a couple of ways that you can put these in. The thing that I want you to remember, danger, 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 is that you can get away with an outgoing interface only, but that's typically only for serial interfaces. And this brings up my preference and what I think you should always do. What you want to use is the next hop IP address. Now, what that next hop IP address is depends on how you want to do your routing. I prefer globally unique addresses in the case of IPv6 or the next router. So this is an IP address of a router that is not you, but is somebody that you can reach. So the next hop, and then you can say, here's the interface that I'm going to use to get to that next hop. Now, global unicast, and we'll see exactly what this means here in a little bit. So I'm going to say some stuff and then we'll go through it to see where it makes sense. Okay. If you use a global unicast, my preference, it's an iterative lookup because what you're saying to the router is, I want you to use this forwarding route or this next hop IP address for this particular network, but do I know where that next hop IP address is? So you have to go through the routing table again to see if you know it. Now this will be on one of your directly connected routes, but you still have to ask that question. You can do unique local and the same thing happens. If you do link local unicast for your forwarding router IP address, you must use the interface because there are no routes for link local addresses. Okay, so let me say that again. If you do a global unicast, you don't need the interface, but you could put it there. And if you do link local, you must have the interface because there's no link local addresses in the routing table. So when we do an example like this, where we see that I want to get to the 1111 network and I'm going to go via 4444.251, The first question is, all right, how do I get to this destination network, the 1111? And you say, oh, I've got a forwarding router's IP address. And then the next question is, do you know how to get to that forwarding router's IP address? So that's the iterative lookup in the routing table. Let's take another look at our routing tables to see what we mean. So here we've got static routes via globally unique addresses. These are the addresses of these three routers, router 0, router 1, and router 2. These are globally unique addresses. So if I want to get to the 1111, the 2222, or the 3333 subnets, right, I would go via these router interfaces. So those are in the routing table. But the question is, do I know how to get to this address or this one? And the answer is that I have to look up in my routing table to see if I have a directly connected route for that network. And then so I find this and I go, oh, that means that I can find them. Now in an IPv4 network, that means that you could ARP for those routers and you could verify that you could build a frame for them. But in this case, of course, we'll do the neighbor discovery process and see if we can tie those together. Okay, so when we're going to a particular prefix, right, I can set up a forwarding IP address or static route to another router that gets me to that destination. But there are special versions of static routes out there as well. Now we know that I can have a default route on a router. In IPv4, when I do a static route with all zeros for the network destination and all zeros for the mask, that's my default route. Well, IPv6 has the same thing. It just looks a little bit different. So for IPv6, I would just do : then /0, and that would be my default route. I can also have a host-specific route. I could say, well, a route to a particular host, but I include a /128 that would allow me to get to that particular destination. Now, we don't use host-specific routes very often. It's just when we want to control the forwarding of packets to a particular destination and maybe via a different way. But usually that host is under a static route that would be pointing to that prefix. Now the floating static, we've talked about this before. Remember chapter 17 when we talked about IPv4 static routes that are floating. And the big deal here is that you've got a route that's available, but we're ignoring it because its admin distance is inferior. So you've learned something via OSPF. This has you set up a route that has a worse admin distance. And the idea is that if something goes wrong with your preferred route, you're going to fall back to this floating route. So floating static routes are present, and we're just ignoring them because their information is worse than our preferred route. When something happens to the preferred route, the static route that was floating comes back into service. Well, now that we've got these different kinds of routes, let's do a little experimentation with our routing tables. Now I'm going to focus on this connection here. We're going to look at this router trying to get to this particular host. And the first thing I'm going to do is remove the route for that particular destination network. So again, if we take a look at how that was entered in here to begin with, this down here is the 3333 subnet. So it's this one right here. So we're going to remove that. But first we'll test to make sure that I can get to that destination. So maybe what we'll do is we'll add the IP address of this particular node. So 2001 DB8, remembering our, so this is that address right there. Now I know that because, well, we did the configuration for this host, and there's its address right there. All right. So I'm going to remove this route after we verify that we can ping it. There we go. So we know we can get to the destination. So I'm going to get rid of it, and we'll verify that we can no longer ping. Okay, so the first thing I'm going to do is add a host-specific route to that particular node. So we're going to say IPv6 route Now, host specific means I'm going to have a /128 for that particular IP address. So 2001 db8 3333 ::1 /128, and then the IP address of our forwarding router, which will be 2001, whoops, db8 db8 :33, whoops, 4444 : 253. So that is this interface right here. Now, what does that look like in our routing table? Well, here we have two static routes that are two prefixes, and then here we have one that is very specific to a host. Well, let's try the ping again. There we have it, success. So that is a host-specific route to that particular destination. Well, let's get rid of that, and let's do a default route. And so I'm going to say IP route : 0. So let's put in our default route. So let's take a look at what our routing table looks like now. And we can see that I don't have anything specific to the 333 network. I have the 1111, 2222. I'm connected to the 444, but now I have this default route up there for all destinations. So I wouldn't do this right in a normal situation. This is a stub network, right? But it's great for this demonstration. So let's try to get to our destination again. And there we go. Okay, so that is static route with straight up global unicast address, a static route that was a host specific, and then static route that was a default route for IPv6. All right, now when you're troubleshooting, we all make mistakes, but router interfaces can also go down, or there can be losses downstream. So there's two generally broad cases. One is where you've got a routing table entry in there and it just doesn't work. You can see it in the routing table, and for some reason the forwarding isn't working. Now, packets in ICMP can tell you an awful lot whether or not they're getting to the destination and if there's any feedback from ICMP. So the things that we want to look at are, right, take a look at your routes. Is it the correct subnet? Is your next hop correct? And what is the interface? And did you determine whether or not you needed an interface in your command? The other case is you entered the command, right? You put the routing table entry in there, but then you do a show IPv6 route and there's nothing there. And there's a couple of reasons why that might happen, right? The interface is actually down, so the routing table can't accept the entry. The route to the next hop is not reachable. So in the examples that I did, if the 4net was not actually reachable, then my forwarding entries that depended on that would also not be reachable, so they wouldn't be installed. And then maybe there's a route from a better admin distance, and this is what we see with floating static, right? I've got two routes that go to the same destination. One is better than the other, so I'm going to ignore the worst one unless this one goes away, in which case the floating route will come back. And remember that the router doesn't check to see if your entry is correct, right? If you use the right IP address or the right mask, it just checks syntax. Okay, so let's try one more thing. I'm going to remove our default route. And actually, in futzing around with these, I've made mistakes too. So it's important that you realize what you're trying to do and maybe be able to do some of the troubleshooting that we were just talking about. What I'm going to do now is try to put in an entry for that destination, but using a link local address. So we'll now do a show IPv6 route, and we'll verify that nothing is in there. And we'll try to get to that same destination. So this fails now because I have no way, right? I have no globally unique address to go through. I have no default route, and I don't have a host-specific route. So what we're going to do is a static route that's based on the link local address. So I do a show IPv6 interface, and I can see that I've got G000 here, but this is for the 3net. I need to go via the 4net, or the 4444 net. So that's this interface, and right there is my link local address. And we can see also that this is an EUI 64 address. So we're going to copy that. Now I'm going to come right back over here and try to use a static route to that particular prefix using a link local. So it's the same destination. So that would be the network destination. And then we're going to say, well, let's try this with a link local. Now, we're getting an error. Now, why are we getting this error? It says the interface has to be specified for a link local next hop. And the reason for that, if we look in our routing table, there are no link local addresses, so we cannot do that iterative lookup. So what I'm going to now do is say, oh, well, I'm going to go out this interface right here, which is G000. So maybe we'll expand this a little bit to show you what we're doing here. So now it's going to say, we're going to get to this interface that we need. So we're going to say G0/0/0. Now we'll paste this and we'll see how it works. Okay, so now we're not getting any complaints. Let's do a show IPv6 route again. Whoops. And we'll see what this looks like. Now we've got this route here to the 3333 network and using a link local. Now we'll try that same ping again. So I wanted to keep this in the video. This is how easy it is to screw up. I had a typo in my destination route that was somewhere in here or right as part of the forwarding. But at any rate, I screwed up the entry. So let's take a final look at what I wound up with after using the link local address. So here's the 1111, the 2222, and then the 333 net via the link local address, which requires the interface to be used. So back to troubleshooting real quick. This was an example where I had a route in the routing table, but didn't work because I had a typo. So really, really easy to do. All right, do you know this already? Questions? Router 6 in the figure has been configured with the IPv6 address you see there. The router also creates a link local address. All router interfaces are up. Which of the two following routes will the router 6 add to its routing table? Well, we know now that link locals are not in the routing table, so it'll add a globally unique address for itself and one for the prefix. Question number 2, a router has been configured with that address on one interface and another address on its G001 interface. Both interfaces are up. Which of the following routes would you expect to see in the output of the show IPv6 route connected command? And that would be the two prefixes. Question number 3, an engineer needs to add a static IPv6 route for the prefix 200123. Which of the following IPv6 route commands would result in a working route for that prefix? Well, you can say, I want to get to this prefix plus an interface or just the prefix without the interface argument. And the reason for that is that because we're using globally unique addressing for the next hop. The minute we use link local or a serial interface, we're talking about interfaces. Question number 4, an engineer needs to add a static route for 200123 to the router 5. Which of the following answers shows a valid static IPv6 route for that subnet? This is the one that I like, right? This is an example of a route that would actually work. 200123/64 via 2001/56::6, right? Forwarding hop here is a globally unique address. Question number 5, when displaying an IPv6 static default route, how does the show IPv6 route command represent the concept of a default destination? Well, we just saw this both on the slide and in the demo, : /0. Question number 6, router 1 has a useful IPv6 configuration so that router 1 learns a route for the subnet. The route lists an outgoing interface that is an Ethernet WAN link. An engineer then installs a cellular interface on both routers for WAN backup. Hint, hint, wink, wink, right there. It's a backup, so we don't want to use it all the time. So we're talking about floating static routes here. As part of the configuration, we add this part right here, which is the admin distance. What does the router do in response? It accepts the route, but it doesn't add it to the routing table because there's one with a better admin distance there. And our last question, an engineer types the command IPv6 route to a prefix via 99::9 with an admin distance of 129 in the configuration mode of router 1 and presses enter. If we assume that there's nothing else going on, that means that we're not in an admin distance problem anymore. That means that this forwarding destination can't be reached to the router, meaning that this router is not connected to that particular network, and so there was no route to the next hop, so it doesn't appear in the routing table. All right, chapter what? Look ahead. Well, we're done with volume 1, which means we're going to go start off chapter 1 in volume 2. Now, if you bought the books, don't forget to register your books for extra resources. I mean, I appreciate you watching the videos here, but you have other resources that you can use. So don't forget to use those. In the end of each one of the volumes, if you've checked for those or if you're doing online, there should be an update chapter that tells you the changes, and you can even download a PDF. What we're going to do in volume 2, at least to start, is the TCP/IP transport services. So we're moving up to layer 4, and we're going to start with TCP and UDP right there. Okay, we have finished up this volume with IPv6 routing, and so we've done a lot of IPv6 so far. Hopefully you've got a good handle on IPv6 static routes. So that's static routes with various types of addresses: global, unicast, unique local, and then link local. But then we also looked at host-specific, default routes, and we talked about floating static routes. We also have a pretty good handle on how to process those routing table entries. So I hope you're getting good at it. You feel powerful. You feel strong. Like and subscribe if you're ready. May those packets always reach their destination, no matter what kind of static route you tried to use. And hey, we're on to volume 2, CCNA. You can do this.